Hi, everyone. I just wanted to talk a little bit about the EcoScale Calculator and what it is, how you can use it, and why we'll be using it in organic lab this year. So first of all, it is a tool that you can use, or any chemist would use to evaluate their organic preparations and determine how eco-friendly or green they might be. So you could use this to compare different experiments to each other. So if you had the option of multiple different routes to a product, you could determine which one might be more green using this tool. You could also take a look at a procedure that you're doing and evaluate where the penalties are being applied from the calculator, and then maybe think about whether those aspects of your experiment are really necessary. For example, you might have a long heating step in your reaction that is causing this penalty on the EcoScale calculator, and it might cause you to consider, well, do I really need to be heating it for so long? Maybe I could run it at room temperature and it would do just as well. So that's the purpose of it. And now I'm just going to go over how to use it briefly. It's meant to be fairly easy and user-friendly. So all you have to do is type in under this reagents area the chemicals that you'll be using. So I'll use experiment 2 from the fall semester organic lab as an example, which is liquid-liquid extractions. So in this lab, we're going to be using diethyl ether for our extractions. So I just type it into the identifier and it will autofill the rest of the information that's necessary. So then you can just add lines for however many chemicals you'll be using in an experiment. For liquid-liquid extraction, we'll also be using water. And then we're going to be using sodium hydroxide. And then if it's unsure of which chemical you're using, it'll pop up a box like this. You just click on whichever one you meant. And you can even type in sometimes abbreviations. So instead of typing out hydrochloric acid, I can just type in HCl. And again, the options will pop up and I can just select the one that I want. We're also going to put in our chemicals that we're going to be analyzing in this experiment. So in this experiment has unknowns, but I'm just going to put in one of each type of possible unknown. And that way we'll kind of get a selection of the different kinds of chemicals that we could be using in this experiment, since we'll be working with unknowns. All right, I think our last one is sodium chloride. Okay, and so now we have a nice list and it generated this beautiful table of all of the chemicals that we'll be using in this experiment. You can also fill out these milliliters, grams, moles, equivalencies. You don't need to do that necessarily for the pre-lab because what it's used for is calculating the yield. And since we don't have a yield yet for our product, that's not really necessary in this case. But if you wanted to go back and put that in at the end of an experiment, that would also help you determine how green it was in practice versus what we're doing now, which is just theorizing how green it is likely to be. So since this is a purification experiment, we don't actually have any products, so we're just going to skip over that section. And if we go down to conditions, since it's a purification, we're going to assume that our yield is around 99%. Again, we could go back and adjust that based on the actual yield that was obtained. Also, if you were following, for example, a literature procedure and there was a yield noted in that procedure, you could put that in here to find out what the yield is more likely to be. Again, for this example, we don't have a technical setup or a temperature and time because we're not actually running a reaction. We are doing a workup and purification. So we're going to come down to this area and we're going to be performing a liquid-liquid extraction. So we're going to find that in here. Here it is, liquid extraction or washing. And then also, as we're going through here, we will be removing the solvent, the diethyl ether at the end. Diethyl ether has a boiling point of less than 150. So we select that one as well. And so now that's it. We have our EcoScale calculation for that experiment. And we can note that number and again, compare it to other experiments if we'd like, or think about ways that we could reduce that number if we wanted to. If you're interested in understanding where all of this came from and how these calculations were determined, you can just click this little tab here where it says paper, and it will bring you to the paper that talks about all of those things. Also, if you get stuck or have questions along the way, there's a little tab here for manual as well, so that's a good thing to note too. So if we actually look at the paper, you can see that they have all of the penalty points for calculating the eco score listed out here. So the price is considered as one of the things, then safety is considered, and different penalties are applied based on how unsafe the chemicals that you're using are. And then the various setups have rankings based again on how green of techniques they're using. And that's really it. If you have further questions, definitely feel free to contact me. But I hope this was a helpful little demo in getting you started with the EcoScale calculator.